We will talk about chords and the special properties of chords. So chords, if you remember, are they have their endpoints on the circle. So AB is a chord, CD is a chord. Remember that a diameter is also a chord. It's just a special kind of chord that runs through the center. So two chords are congruent. We can tell if they're congruent if and only if. There's that if and only if again that we did in Unit 2. If and only if means that both conditions have to be met. So if you know one, then you know the other. So if and only if their corresponding arcs are congruent. So we have, when you have a chord, it cuts an arc out of the circle. So if the chords are congruent, then the arcs are congruent. If the arcs are congruent, then the chords are congruent, because it's if and only if. So in this example, the measure of AB equals the measure of CD. So they're congruent because their measures are equal. So if that's true, then the measure of arc AB is equal to the measure of arc CD. So see the arrow? This is the if and only if. So the arcs have equal measure only if, the chords have equal measure only if the arcs have equal measure, and vice versa. If the arcs are equal, then the chords are equal. The second condition is that the chords, the two chords, are equidistant. Remember that word starts with equa, which would mean equal or same, and distant would be the distance. So they are equidistant from the center. So let's look at that. Okay, here's their arcs that they cut off, and then here's the center. So this distance from the center to chord AB is going to be equal to this distance from the center to chord CD. So the two chords are equal. Their measure is equal. That's what it means when we don't put the segment over the top. Their measure is equal if and only if the EF and EG units are the same. So if the chords are congruent, then the arcs are congruent, then the distance from the center to the chords is congruent, is the same. Now, the other thing that I apparently left out of your notes that we really need to know is it's marked here. It's marked perpendicular. So if the radius, now you can see that this distance that I measured to the chord, if it kept going to the edge of the circle, that would be a radius. If the radius is perpendicular, remember that upside down T is the symbol for perpendicular to a chord, then it bisects the chord. Bisects, two cut, and two. So it cuts it into two equal pieces. So that means this is congruent and this is congruent because it cut it into two equal pieces. I should put two marks so it doesn't look like it's equal to that. So let's use this information, these properties about congruent chords to answer these questions. Number 1 says find the value of X. So do you see the congruent marks? That means these chords are congruent, and we just learned that they're congruent if and only if the arcs are congruent. So this 115 must be the same as the 7x plus 24, so I will set them equal. 7x plus 24 equals 115. I'm going to take away the 24. Don't feel like doing that one in my head right now. 91, and then I'm going to divide by 7. So x equals 13. Now, it didn't ask us to plug it back in to find any measures. It just said find the value of x. On example 2, find the value of x, we see that in this one, they told us the arcs are congruent. But we know the arcs are congruent if and only if the chords are congruent. Therefore, we can set this equal. And we're going to add the 2 and then divide by the 18, and we find out that x is 3. All right, this time we are asked to find the measure of xy, and we cannot find the measure of xy until we find this x right here. So let's see what we know. We know the arcs are congruent because of these little marks here. Therefore, we know that the chords are congruent, the chords that make those arcs. So we're going to set them equal to each other. I'm going to say 9x minus 34 equals 4x plus 1. I'm going to subtract the 4, add the 34, and x is 7. But our question did not ask us for 7. It asked for the measure of xy. So we find our xy. Where's xy? Does it matter which of these we plug into? It does not, since they are congruent. But I'm going to choose the one with smaller numbers and positives. So instead of x, I'm going to put 7. And the measure of xy is 29. Okay, let's look at another one. The next one wants us to find arc. The measure, that's what that M means, of arc, RS. So where's arc RS? Right there. It's got to be congruent to that arc because the chords are marked congruent. They're congruent if and only if the arcs are congruent. So let's set up our equation. Let's set them equal to each other. Then we're going to subtract from both sides. And we're going to say that x is 13. Oh, but I don't want x. Forgot what I was doing for a second. I want the measure of RS. Once again, these are congruent, so it does not matter which one I plug into. I'm going to choose the numbers that are smaller and positive. And I'm going to say 5 times 13 is 65 plus 6, 71. I believe the measure of arc, RS, is 71. I'm going to check that in my calculator. Yes, I did the math right. Okay, let's go to this example. This one says find x. So what do we know? We know the chords are congruent. They're marked congruent. Therefore, the arcs have to be congruent. But I don't have anything to set this equal to, but I do know this one is 76. So I know the whole circle is 360. Let's take away the 76 that they gave us, and we get 284. So I have 284 degrees left for the rest of this circle. Now, don't I know that these are congruent because the chords are congruent? Therefore, couldn't I just divide this by 2 and get that each arc is, excuse me, 142. Therefore, 6x minus 20 must equal 142. And I add the 20, and I divide by the 6. And x is 27. Is that what it asked us for? Yes. One more. If the measure of MP right here is 5x minus 34, and the measure of PN is 2x minus 4, find MP, the measure of MP. Well, that was our second if and only if up there, was that if the arcs or chords are congruent, which they are, arcs are marked congruent, therefore chords are congruent, therefore, what was that second if and only if? They're equidistant from the center. So let's set them equal. So 5x minus 34 equals 2x minus 4. I'm going to subtract 2x. X is 10, but I don't want 10. I want MP. Does it matter which one we plug into? Not at all, because they're equal. Once again, I'm going to choose the smaller numbers. 2 times 10 minus 4, 20 minus 4. The measure of MP is 16.